All right, IM3 classes. Today we are continuing on with our lessons of how to solve quadratic equations. The two methods we've learned so far is factor and then solve. We learned how to complete the square and then solve using square roots. And today we're going to learn about the quadratic formula. So first, the quadratic formula is this big long formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula is used to find the value of x in quadratic equations. So those are polynomials with degree of 2. So when you use the quadratic formula, so if you can factor a quadratic equation to and then solve it, you should do that because that's going to be the fastest and easiest way. So factor and solve should be the first thing you should check for. If the quadratic does not factor, you can use either completing the square or the quadratic formula. Completing the square works best if the x squared term does not have a coefficient. All right. Quadratic formula would work best if the x squared term does have a coefficient. This would be the easiest way, even though it doesn't look that easy. What we're going to do today is start out with the discriminant. So the discriminant is the part of the quadratic formula that is underneath the radical. All right, so that is this part in here, b squared minus 4ac. The discriminant actually tells us how many solutions a quadratic equation has. The possibility for the solutions that it has is 2 solutions. If b squared minus 4ac turns out to be a positive number, the equation is going to have 2 solutions. If b squared minus 4ac is equal to 0, then it means it has 1 solution. And then if b squared minus 4ac is less than 0, it's negative. That means it has no real solutions. It would have imaginary solutions is what we would call them, or complex solutions. And we'll get into complex solutions later on. We're not going to be dealing with that today. Where do A, B, and C come from? Just a reminder, same place like they did with the completing the square. They come from the quadratic equation. So the general equation for a quadratic is ax squared plus bx plus c. A is always attached to x squared, B is always attached to x, and C is always by itself. Again, if the quadratic doesn't factor, your next best option is to solve by completing the square. Completing the square works best if A is 1, if the coefficient on x squared is 1, and if B is an even number. You can still do if it's odd, but it's a little bit easier if it's even. If it doesn't have those, quadratic formula is the best way to go. What we're going to do here is just work out some discriminant real quick and evaluate that. So we have x squared plus 5x plus 6 is equal to 0. How many solutions does it have? First thing I'm going to do is identify the A, B, and C. So A is 1, always attached to the x squared. The B value is 5, C is 6. And I'm going to substitute these values into b squared minus 4ac. So b squared minus 4ac, b is 5, a is 1, c is 6. I'll do some highlighting just to be clear. So a is 1, b is 5, and then c is 6. All right, evaluate that. B squared 25 squared is 25. Minus 4 times 1 is 4 times 6 is 24. 25 minus 4 is 1. All right, that disappeared. Since this worked out to 1, since b squared, since the discriminant b squared minus 4ac is greater than 0, that means it has 2 solutions. All right, let's look at another example. bunch of negatives on this one. Oh, first thing you need to be careful. Make sure you're reading these carefully. This is out of order. All right. So if it's out of order, make sure you put it into correct order. I need to switch the negative 4x and the negative 7. If it's out of order, you might mess up with the A, B, and C. So A is negative 3, B is negative 4, C is negative 7. So I'm going to put those values into the discriminant b squared minus 4ac. So b squared minus 4 times a times c. B is negative 4. A is negative 3. C is negative 7. Keep track of all these negatives. I want to make this plus a negative, just to help keep track of all the negatives there. Negative 4 squared is positive 16 plus negative 4 times negative 3 is positive 12 times negative 7 is negative 84. 16 minus negative 84, that's going to be negative 68. Yeah, negative 68. So therefore, since b squared minus 4ac is less than 0, it's negative, there are no real solutions. We're just going to have complex solutions on this. One more discriminant. How many solutions does this equation have? Check it is in the correct order. I'm going to identify my A is 1, B is B is 4, C is 4. Put it into b squared minus 4ac. B is 4 squared minus 4 times 1 times 4. 4 squared is 16, minus 4 times 1 is 4, times 4 is 16. And work that out. 16 minus 16 is 0. All right. Since b squared minus 4ac, since the discriminant is equal to 0, that means there is one solution. All right, let's actually move on to now putting this all together into the actual quadratic formula. So we're going to use the quadratic formula to solve. First step is the same. We're going to identify A, B, and C. I think it is important to still use the discriminant because that's going to make this last part not as messy when you're going through here. So first it's going to be A is 9, B is negative 8, C is negative 13. So first thing we're going to do is the discriminant, b squared minus 4 times a times c. That is b squared minus 4 times a times c. So b is negative 8. A is 9, c is negative 13. I'm going to make this plus and negative 4 just to help keep track of all the negatives in there. 8 squared is 64 plus negative 4 times 9 is negative 36. I'm going to use a calculator. So negative 36 times negative 13 is 468. Wow, that's a big number. 468, add that together. We get 532. All right. So the next step is I'm going to use the quadratic equation now. So bx is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to make this simple here. I'm going to replace b plus or minus. I already found the discriminant, so I just need to replace it with what we found here and then over 2a. So the other nice part about doing the discriminant first is once I go to plug into the quadratic formula, I only need to plug in 3 values. So the discriminant 532 is going to go in here. And then we have B is -8. Be careful with the negatives on there. So it's -8 that goes in there. And then A is 9. So we get -8 is +8 plus or minus the square root of 532 over 18. This simplifies more. We can simplify this radical. We can divide that a little bit, but we're just going to leave it like this. We're going to keep it simple. Plug it in. We're done there. All right. Let's do another example. B squared plus 11b plus 20. So first thing I'm going to do, identify A, B, and C. I'm going to plug in the A, B, and C into the discriminant. B squared minus 4AC. So B squared not equal minus 4AC. B is 11, A is 1, C is 20. So 11 squared is 121. 4 times 1 is 4 times 20 is 80. And that got messy. Let me clean this up. Uh, 121 minus 80 is 41. Right. So it does have, it's positive. So it does, again, it has two solutions. So next I'm going to use quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So -b plus or minus the discriminant is all I need to put in there, all over 2 times a. So b is 11, the discriminant is 41, a is 1. Then just simplify, so it's -11 plus or minus the square root of 41 all over 2. And that actually does not simplify. So let's get that. And that is it for today. If you have any questions, make sure you let me know. Other than that, we'll see you guys next time.